Okay, 6.4 is our last section on dilations. Um, and a dilation is another word, or another way to think of a dilation is like a projection. Um, and a dilation has a center of dilation, which is a point. And so in this picture here, this point right here will be our center dilation. Um, and then you have an image, and you have well, you have your original and then the image of your original. So for example, if this is my original ABC, so we have this triangle, and we're going to create an image of that. So this, we're going to use the same ABC, but we're going to put primes on them to say that point A is going to correspond to A prime, B will correspond to B prime, C will correspond to C prime. And they correspond the two triangles are similar to each other when you do a dilation. Also, because they're similar to each other, you have some kind of scale factor. So let's say the side lengths were 2, 3, and 4, and say my scale fact. Well, let's just put and I do this dilation, and let's say A prime B prime ends up being 5. So what would my scale factor be? As a fraction, what would that be? 5/2. So we can always do this because scale factor is what you're multiplying by to get the new values, right? And so if I'm going from 2 to 5, I'm thinking, well, 2 times what scale is equal to 5, and you divide by 2, and you get your scale factor would be 5/2. Also, if you were to draw a line through the center and through one of your points on your original figures, so like say I drew a line from through the center and point B, if I were to extend that line would also go through B prime. Or if I went through the center through point C and kept going, it would also go through C prime. So that's just one of these ways the dilations work. Okay, so we're going to look at some problems involving dilations and work through them. And I'm going to kind of move around. I'm not going to go in the same order that things are here. But let's first look at this second one here. They're not numbered, but sketch ABC. So we have triangle ABC, and they have given coordinates. And they say if triangle ABC has a dilation by a scale factor of 1/2, using 0, 0 as the center of our dilation, first we're going to make a prediction. So we can be wrong with our prediction, but we're going to make a prediction. What would the new points be? So if our scale factor is 1/2, and these are our original points, what do you think, like if A is 4, 2, and our scale factor is 1/2, what do you think A prime would be, just as a prediction? Yeah, Luis. 2, 1. So you're just cutting them in half, right? And it's a good prediction. What about B prime? 3, 2, and C prime? 1, 4. And it turns out that you guys are right. Okay, it is kind of what it seems like it should be. And so let's go ahead and verify that, but plotting A, B, and C. So 4, 2 is A, 6, 4 is B, and 2, 8 is C. So that's the original triangle. The center is at 0, 0, so there's our point. And then A prime, we said is at 2, 1. B prime at 3, 2. And C prime at 1, 4. And so because our scale factor is 1/2, I mean, there's a couple ways to check that. So if you find a length in your original, so if I find the length from A to C, the length from A prime to C prime should be exactly half of that. And we'd have to use the distance formula to verify that if we wanted to. Another easier way to look at that is, well, if we look at, if I want to go from my center to point A, I have to go right 4 up 2. If I need to go from my center to A prime, I'm going right 2 up 1, which is kind of, you're cutting things in half, and then you can show that that's half the distance. Another verification here is if I could, if I draw this, so up 1 over 2, up 1 over 2, and you see it extends through A prime and A. Also with C, I go up, C prime, I go up 4 over 1. If I go up 4 over 1 again, end up going through C, and so on. So we have our center of our dilation and our projection here. Let's look at this one now. So we have a center of dilation at 0, 0 again. And the X and Y axis are kind of hard to see in this picture, so I'm going to highlight them. The y-axis is not centered, okay? And we want to graph and label each figure and its image under the dilation k equals 5 over 2. So this right here, k equals 5 over 2, what do you think that is? That's our scale factor. Okay. And they give us the points D, E, F, and G, so that's our original quadrilateral. And so let's start by plotting those. So 0, 0 is D, 2, 4. Right there is E, 6, 2, F, and G is going to be 4, negative 2. So we get that shape. It looks like a square. What do you think? Actually, we could prove it's a square. I'm not going to do that, but you could show that these are perpendicular to each other by looking at their slopes. You can also show they're the same length by using distance formula. It looks like we got a square tilted on its side. Okay, and our does it say what? The center dilation's at 0, 0. Okay, so right here is the center of our dilation, and we want to come up with our new points. And our scale factor is 5 over 2. So let's start with F. If F is 6, 2, what do you think F prime is going to be? If their scale factor is 5 over 2. So scale factor is what you multiply things by, right? So if I multiply 6 times 5 over 2, I get 30 over 2. And if I multiply 2 times 5 over 2, I get 10 over 2. And I can reduce those. And I get 15, 5. And that's where our F prime is going to be. 15, 5. So 15 is the very far last marker on here, right? And up 5 So there's my F prime. How about G prime? So 10, negative 5. Okay. And how about D prime? 0, 0. And last one, E prime. You multiply 2 times 5 over 2, you're going to get 5. Multiplied by 4, you're going to get 10. So 5, 10. And there's our projection or our dilation, 2.5 times bigger than the original. Okay. Let's now look at the one next to it, the trapezoid one. So create a dilation of the trapezoid ABCD with the center dilation at the origin and the scale factor being 2. You can also write that as xy goes to 2x times 2x and 2y, so you're multiplying all your coordinates by 2 to get the new one. So I want you to fill out what A prime, B prime, C prime, and D prime should be. I want you to draw that. And then you got a couple questions about it. Okay, down here you got what's true about CD and C prime, D prime. Can you justify that mathematically? Can you find the areas of the two trapezoids? Can you find the ratios of those areas? So I'm going to give you a little time to work ahead on this and see what you can do with that. These are the coordinates you should get. So what do you think? CD, the line CD or the segment CD and the segment C prime D prime. Any ideas about what might be true about those two things? You look at them. Yeah. Okay. So the slopes are the same. So let's see. What is the slope from C to D? I'll do that as M. M for slope. Hey, what's the slope from C to D? Is it positive or negative? negative 4 over 1, or negative 4, right? How about the slope from C prime to D prime? So you're dropping 8, so it's negative 8 over 2. Is that the same thing as negative 4 over 1? Okay. And so what do we know if you have same slope? What can we say about this? They're parallel to each other. All right, so what's true? They are parallel. Justify mathematically, we showed that they have the same slope. Okay. All right, now let's find the areas of these trapezoids. Do you guys remember how to find the area of a trapezoid? So the area, for example, of the smaller one, A, B, C, D, is going to be 1/2 times base 1 plus base 2. Because we got two bases, so for example, base 1 might be the shorter length here. I'll call that base 1. Base 2 would be the other base. We know that with trapezoids when we looked at them, they have two bases, and they're parallel to each other, times the height. So in this case, we get 1/2. How long is base 1? 2. How long is base 2? 5. What's the height of this thing? 4. So you just look at the picture, you could see, okay, base 1's the length of 2, base 2's the length of 5, and the actual height is got to be perpendicular to the bases, right? And so that's the length of 4. And so we can plug that in, and we get 1/2 times 7 times 4. 7 times 4 is 28. Half of 28 is 14. So 14 square units is the area of ABCD. So do the same thing. Find the area of the larger trapezoid. What are we getting? What is it? 56. 56. Because you have base 1 is 4, base 2 is 10, the height is 8. Notice the base 1, base 2, and the height are all double the original base 1, base 2, and the height. And that's because of our dilation has a scale factor 2. And then you work through it and you get 56. All right, did we finish this problem? Did we do everything it asked? There's one more thing. What's the ratio of the areas of the trapezoid ABCD to the other trapezoid? So a ratio is a fraction, a proportion, well, not a proportion, but a fraction. And when you make a fraction of these two numbers, the 14 and 56, which one goes in the numerator? The 14, because of the way it says it. So it says the smaller to the bigger, so 14 over 56. Does that reduce? What can I divide those fractions by? 14, and you end up with 1 out of 4. So that's the ratio of the areas. Okay. All right, try this this one right here. Use the graph to find the vertices of the image for a dilation with center 0, 0, and the scale factor. So this is the actual value. We don't have the image on here. You don't have to graph the image, but I want the vertices of the image with that center 0, 0 and scale factor 1/4. Give that one try. with the picture, it might be hard for you to see where the coordinates are, so I wrote them here. Just make sure we're using the same coordinates, Q, R, T, and W. Those are not the answers. Those are just the starting point. You want to find the image of those coordinates. This is what you want right here. Q prime, negative 3/4 and 1. R prime, negative 1/2 and negative 1/4. T prime, 3/4 and 1/4. And W prime, 3/4 and 5/4. So we're just multiplying our coordinates by the 1/4 to get these new coordinates. Okay. What do you think about the question below it? Will the sides of the new quadrilateral be parallel to the sides of the original? And it is true. There's a lot of detail into why that we're not going to have time to get into, but just know this, that corresponding sides in a dilation are not, they're not congruent, but they're parallel. And they're proportionate too, because we have similar figures. So I'm going to stop there. We'll consider this worksheet done. I know we didn't do all the problems on it, but you don't have to do any more on this worksheet. Your homework's going to be the review. Start to finish, have that done. By Thursday when you're with me, there's a video online if you need help with that. But I think most of them are going to be pretty good and straightforward, okay? So please work through that.